that turned up.
And Josh said that when he looked over, he like all of a sudden he was like, for a hot second, he was like.
Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh, it's the Science Café with your host, Brian Mallow.
Good evening, everybody. Hello. I guess we need an applause sign. Welcome to the Daily Planet Cafe here in the Nature Research Center at the North Carolina Museum of Natural Sciences. It's Thursday night, and that means it's Science Thursday here, and this is our Science Cafe. I see a lot of familiar faces, but I see a lot of unfamiliar faces. How many people are here for the first time for our Science Cafe? Excellent. Water is a good, important subject. Is that the music is playing? We're going to cut the music and do this show a cappella. So, water, yes, water. Sometimes it's underappreciated, but this is National Estuary Week, and this is also capping a series of talks that we've had in the Daily Planet. This is the Daily Planet Cafe, but in the Daily Planet Theater, we've been working with APNEP, the Albemarle-Pamlico National Estuary Partnership. And we've been working with them, and they've provided a series of speakers on a variety of topics related to water and estuaries. And in fact, the director of APNEP is here, and before he's going to introduce our guests for us, and I'm going to introduce you to him. So, ladies and gentlemen, how about a nice round of applause for the director of APNEP, Bill Kroll.
Thanks, Brian. Thank you all for coming out tonight, and it's my pleasure to introduce Dr. Reide Corbett. He's a professor and senior scientist at East Carolina University and the head of the Coastal Processes program at the Coastal Studies Institute located out in Roanoke Island. Albemarle-Pamlico National Estuary Partnership, or APNEP, because I don't answer the phone with that name every day, is a program that is funded by the EPA and is hosted by the Department of Environmental Quality here, and in partnership with a lot of organizations, including the museum. Our mission is to identify, restore, and protect the significant resources the Albemarle-Pamlico estuarine system. And that's the Albemarle Sound, Pamlico Sound, Currituck Sound, Croatown Sound, the Bogue Sound, and Core Sound. And it's a system in which the waters from this area and all the way up in Roanoke, Virginia, flow out through our sounds and out through a couple of inlets in the Outer Banks, and the sounds are bounded by the Outer Banks, and we're going to hear a little bit about our water there and our processes there and what's happening with that interrelation. So welcome, Dr. Reide Corbett.
Thank you. I appreciate everybody coming out. This stage is a little I feel like I'm on The Voice. My wife made me watch The Voice for the first time the other day, and so I'm going to try not to break out in song. But hope to introduce you to some of our estuarine systems and our very large coastal system that we have in North Carolina. North Carolina is lucky in many ways to have such an extensive estuarine and ocean system. It's very diverse, and many of us haven't sort of experienced the diversity of the system. But what I want to focus today is sort of the interaction that we have between land and ocean and some of the dynamics that are occurring along our coast. And my background is sort of a marine geochemist. I'm interested in the connection between land and ocean. And my research, I thought I'd just give one slide that sort of focuses on some of my research, to give you some examples of what I do as an academic. And I should say that I was told to sort of give a talk of about 20 minutes. I am an academic. You know, I could talk about my name for 20 minutes, right? And so I'll try to get this through in 20 minutes so we have time to sort of discuss and talk. But I do want to introduce you to me, and my real interest is in that connection between land and ocean. And a lot of my work focuses on the dynamics between the land and the ocean and that exchange that occurs within estuarine systems. I work on groundwater, surface water exchange in coastal systems. I'm just finishing up a project in the Antarctic, which you would think wouldn't be important for groundwater. It's a frozen continent after all, but there's really some interesting melting going on and exchange that's happening there. I do a lot of work on major rivers like the Mississippi River and others, looking at how sediments and water are transported to our coastal ocean. And what I want to focus on today is really looking at the coastal change that's occurring. We do work sort of around the globe, but I want to focus on North Carolina. And I love I grew up in North Carolina, and understanding and studying this system has been a great part of my career. And I couldn't really talk about coastal North Carolina without at least mentioning two names that have been, well, often cursed, or people love them. They either love or hate Stan and Orrin when you talk about coastal North Carolina. These guys have been very vocal about our environment, about saving North Carolina for ourselves, for the future. And they've been advocates throughout their career. These guys have been around forever, maybe not as long as some of the maps I'm showing you, but certainly have been around and studying and talking about and trying to teach people about our coast for years. And so I always have to sort of give this shout out to Stan and Orrin, just because they have been sort of a staple of coastal North Carolina and trying to understand the changes that have taken place with time. The maps that I have up on the screen are showing some of how the coast has changed through time. This earliest map is in the 1700s, and it runs through about the late 1800s. And you can see that our coast, these aren't because people didn't know how to draw maps in the past. Right? The fact is, our coast has changed dramatically in the last several hundred years. In fact, both of these gentlemen, what they always, and they still say, is there's nothing constant along the coast except for change. So I want to try and address some of that change that occurs along the coast. When we think of coastal North Carolina, it is one of the most vulnerable coasts that we have in the U.S. And there's a reason that we're very vulnerable. Right, we're familiar with hurricanes, but hurricanes aren't the only storms that we have. And in fact, if anybody was on the Outer Banks this week, or if you plan on vacationing there this weekend, I suggest you cancel. Because we have these nor'easters that come through all the time throughout the winter. And so we get all kinds of storms. Now, I've sort of placed this map and showed you these tracks of hurricanes, tropical cyclones, but those aren't necessarily the most devastating. The worst storm that ever occurred on the Outer Banks was actually the Ash Wednesday storm. Did some of the most damage, and that was just a strong nor'easter during a major high tide, right? So our system is familiar with storms, but it's these storms that can create change. That's one reason we're fairly vulnerable. Another is that most of our coastal plain is fairly low-lying, right? We're only a few feet above sea level, well inland. And this large map on the screen in front of you sort of gives you an idea of the elevation. The reds are an indication of very low elevation, roughly a foot to 2. So extremely low elevation, right? So inundations, whether it's storms, wind tides, or major tropical cyclones, right? The potential for inundation is really high along our coast. And then finally, there are changes that are taking place with sea level rise, with the potential change in storms. Our coast is becoming more vulnerable, potentially now, than ever in the past. And if we're to understand some of this vulnerability, we need to look at what our coast is and try to define what our coast is. Now, when we think about the coast, we often think of the ocean front. And there's a good reason for that. We have beautiful beaches. We have some of the most beautiful beaches in the U.S. Now, North Carolina has about 300 miles of Atlantic shoreline. Wonderful Atlantic shoreline. Much of it undeveloped, right, under national park. What's interesting is what we don't consider is what's actually behind that Atlantic shoreline. So we have 300 miles of Atlantic shoreline, but we have more than 12,000 miles of estuarine shoreline. Right, that's an impressive number. We have the second largest estuarine system in the U.S. with 12,000 miles of estuarine shoreline. And so sort of defining what the coast is in North Carolina is pretty important. It's not just those 300 miles of oceanfront shoreline, but we need to consider that 12,000 miles that lies behind the barrier islands. Now, I do sit around at times and make very complicated slides because it interests me and it sort of helps me define what I do, right? And so this is a busy slide that's trying to take some of my interest and put it sort of conceptually into a picture. And what I want you to focus on are those words in yellow. And those really focus on sort of the processes that might drive change in the coast, right? Shoreline change is referring to how shorelines are either retreating or accreting, right? Moving back and forth. Marsh accretion, right? We're very concerned about what our marshes are doing vertically. Are they keeping up with changes in sea level, right? Marshes are critical habitat for fish and other things. Saltwater inundation, as sea level rises, as we continue to pump our coastal aquifers, saltwater is moving into our coastal aquifers, leaving coastal freshwater aquifers, potentially moving saltier and saltier, right? So those freshwater resources becoming more scarce. And so all of these processes can lead to change. And so if we're to understand how this change is going to affect sort of you and me and the coastal environment, well, we have to understand the coast and these processes and how they're actually driving change along the coast. And so those are a lot of my interest, is sort of focused on some of these processes and understanding these and understanding how they change the coastline. Well, the coastline, how do you define a coastline? 5 years ago, North Carolina didn't really have a defined coastline. Now, you'll see what I mean in just a minute. But if you could think of the many agencies that are focused along the coast, whether it's Division of Marine Fisheries, now Department of Environmental Quality, and the many divisions within that, right? Everybody sort of defines the coast a little bit differently. And we met with the Division of Coastal Management and said we should probably all be using the same boundary when we focus on the coast. And so we sort of created a collaboration with the Division of Coastal Management and decided to define the coast digitally, right? So everybody was working with the same defined coastline. And again, this isn't just that Atlantic coastline. That's been defined for a long time, pretty easy to delineate. But you have 12,000 miles of estuarine shoreline. How do you define that? And so that's what we're really interested in. And if we want to define change, you need to start somewhere. And what does change mean? Are we talking about how the shoreline is changing, how we're developing it, how we're actually changing the shoreline, right, with different types of structures and things of that nature? And so what we did is basically digitally define the shoreline. And we did that. If you can imagine a sweatshop of graduate students and undergraduate students sitting in the lab for hours at a time, clicking away at a computer at 12,000 miles of shoreline. Nobody went nuts. And we did it. It took us about 2.5 years, and we digitized just over 12,000 miles of shoreline. And when we did that, we attributed that shoreline. What in the world does that mean, attributing the shoreline? So that's GIS talk for saying we basically, for every line that we drew, we stated what that line was. Was that line a marsh? Was it a swamp forest? Was it a sediment bank, a sand beach? Was it modified? And if it was modified, how was it modified? Right? Did it have riprap? Did it have a seawall? Right, so all of this has now been digitized and is available when you're bored, right, to go online and check it out. Use that data however you want. And so, but it is really useful data. And these images try to give you an idea of the scale. I've got 2 images. This first one's from Currituck. And if you sort of start from the left of your screen and follow those red arrows, it gives you start zooming in, right? So that first little green scale is all 20 the coastal counties. And then we zoom into Currituck County. You can barely see some of the different colors. And then you zoom into a very specific point within Currituck County. And all of a sudden, you can see all these dug canals, and you see these different colors of lines. And those different colors represent different types of shoreline. The red is modified, and it's modified by different types of modifications. Again, riprap versus seawalls. But it gives you some idea of the scale at which we're actually digitizing. and the amount of data that we've created. So that's one example. Here's another example, zooming in a bit more. Again, this is Dare County, and that biggest image is at about the scale that we're really doing the digitizing, right? Which is, it's extremely small, right? We don't have very large monitors, but you can imagine we're basically pointing and clicking the entire way. And we haven't just done the shoreline, but notice those yellow polygons. Those yellow polygons are docks. We've digitized every dock in North Carolina. Exactly. I totally agree. Thank you to my students. And we did this to provide a baseline. If you want to evaluate change, you have to evaluate change from some point. So what we've done is provided that point for the state. Now, this first set of images that we used, the actual, and so this is all done from aerial images that were taken somewhere between 2006 and 2009. It depended on which county that we were working on. In 2012, the state flew the entire coastline and all the estuaries. This was all redone with 2012 data, right? So now we actually have 2 data points. You can start looking at change, right? But you have to have that baseline. And so that's what we did. And again, this data is available. This is an old slide. It says DENR. It's now DEQ as of, what, 5 days ago? And so it wasn't old when I made it. But so DEQ has all this data available. You can download all the data. It's public data. You're welcome to it. I encourage you to look at our coastline, right? Look at how it's modified or not modified. Also, we have this collaboration at ECU, and maybe some of you have seen a talk by Tom Allen that focused on the Coastal Atlas. And all of this data is also available on the Coastal Atlas. And so this is a zoomed out image of North Carolina. And you can see all the red is an indication of sort of that digitization that took place. You zoom in and you can start looking at how all the attributing associated with the type of shoreline that you see. Right? That created the baseline. And from the baseline, we can look at change. All right, so what do we do with it? It's a huge data set. Just this baseline of data is a huge data set. What can we actually do with it? I'm going to give you 3 examples of what we've done with it so far. Just larger data set. And so we'll look at some general statistics. Beforehand, we had some idea of the types of shoreline we had, but again, without creating the baseline, we didn't know for sure. And I'll look at some focus areas. And so some general statistics is our shoreline, again, greater than 12,000 miles, is dominated by marsh, right? More than 60% of our shoreline is marsh, which is a good thing, right? Marsh habitat is critical for the ecology of our estuaries and that exchange between the open ocean and our estuaries, right? So that is the habitat that ultimately leads to the fisheries that we know and love. And so, I mean, that's kind of interesting in itself that we're dominated by that. The statistic that I really like and that I want to focus on just for a minute is that black in the pie, right? That 5%. Our shorelines are only 5% modified. Now that is an impressive number. Maybe it doesn't seem like much, but there are watersheds out there. And certainly if we focused on a single watershed, we might see something similar. But on a whole, North Carolina is doing really well as far as not modifying its shoreline. It's something we need to think about. Moving forward is how do we modify our shorelines? Should we modify our shorelines? Where should they be modified? And what sort of policies should we put in place to protect our shorelines? But right now, it's only 5% modified. There are watersheds that are 20, 30, 50% modified with hardened structures. When you start seeing modification of that magnitude, you start seeing a degradation in the ecology of the system. And so, we should pat ourselves on the back. We are doing pretty well. Now, I'm not going to say that that's the case everywhere, right? There are certain areas that are doing a lot more modification, but in general, I would say that we're doing pretty well. So again, some general statistics. We can look at hotspot analysis. And so this is an example of taking a sort of a moving circle, a moving window across the entire coast and saying, where do we have significant modification occurring? And so this is a circle that's about 12 miles in diameter and moving that around the entire coast. And so your hot colors, the reds, the oranges, are areas where you have a lot of modification, right? A lot of hardening of the shoreline. And some of that's not too surprising, right? You see it in certain places of the Outer Banks, Collington Harbor. You see it around Morehead City and Beaufort, these areas where you know are fairly well built and well developed. But there are other areas that sort of poke out as interesting. In the middle of the Pamlico estuary, right around Bath, that was an area that was sort of surprising that we saw significant modification occurring. And it has to do with the underlying geology and the geologic history of that area and what that area really represents that they're having to modify it. It's a huge sand ridge from a paleo shoreline. And that's actually they're having to harden it because it's a lot of sand that erodes very quick. It's mainly sediment bank. And so it's not just development that we're having to harden our shorelines. There are other processes involved that lead to trying to prevent erosion. But one of the most interesting, and especially from my perspective, really interesting things we can do once we have a baseline is start looking at change, right? And again, to look at change, you need to have a baseline, something to compare to. So I want to give you an example of how you can look at change from an environment. And so this is Cedar Island, not far from Beaufort, Morehead City, that area. This is, what I'm showing you here is a marsh. Right, so it's a marsh that transitions into a forest, and although difficult to see, there's a road there, right, just behind the first tree line. All right, so that's just a picture we took from an airplane, and the next series, 2 slides I'm going to show you are from some aerial photos that we've used to map, and this first one's from 1958. And what we've done is digitized several things on this photo. We've got, in purple, we've got the shoreline. In red, we've got a vegetation line. It goes from marsh to forest. And then in yellow is the road, Lola Road. All right, so as an example, if you have a baseline, this baseline's 1958, and then we take another image in 1998, 40 years later, you can start understanding change. And so the lines that are sort of on this particular image are from the 1958 photo. Notice the shoreline has retreated. Right? And that rate of retreat is somewhere between 1 to 3 feet per year on average is what that represents. What's interesting is that notice that vegetation line also retreated. Right? So in this particular instance, we didn't lose any marsh. The area of marsh has remained the same. Now, I should warn you that that's not the case everywhere. Right? I mean, the fact is there's a road there. Lola Road remained in the same location. If that shoreline continues to retreat, right, at some point it's going to run up against a road, and marsh can't jump a road, right? So those sorts of infrastructure can prevent the sort of this moving backwards of not the shoreline, but the vegetation. And so that's a key point that I like to sort of demonstrate here is, yes, the shoreline has retreated, and we need to be concerned about that. But at least in this case, the amount of marsh hasn't changed. You do see the transition. But we should be at least, maybe not concerned, but observe some of the changes that are taking place, right? This idea of shoreline change. And so in many locations around our 12,000 miles of estuarine shoreline, we've done sort of postage stamp studies where we've looked at how quickly the shoreline is changing. For instance, we've looked at the entire Neuse River estuary. This is sort of in our backyard on the Outer Banks. And looking in the area around Kill Devil Hills and Nag's Head. And this is showing 3 different images, and the different colors are an indication of shoreline erosion or accretion. The red colors, your warm colors, are rapid erosion. And the cool colors, the blues, are either no change or maybe some accretion. And so what we're actually able to do here is look at different time steps. And with those different time steps, we can start understanding how the shoreline is changing, but more importantly, what are the processes that are driving that change? Is it storms? Is it sea level? Is it boat wakes? Right? I mean, at this point, when we can start looking at very high resolution time series, we can start getting a better understanding of not just how it's changing, but why is it changing? And once we start understanding why it's changing, we can start maybe doing something about it, or at least thinking about what we might do about it in the future, how we might maybe not prevent it, it's hard to prevent, but living with it and developing in a way that sort of takes this change into account. And so as part of sort of a broader project, one of the things we wanted to do is understand how vulnerable is coastal North Carolina. And so we partnered actually with a group of scientists within the entire Southeast. So North Carolina, South Carolina, Georgia, and Florida. And through a project funded through NOAA, we started looking at vulnerability, not just from shoreline change, but we looked at shoreline change, inundation, and so how water is inundating the coast, primarily by differences in elevation, how low-lying you are. And then this social vulnerability index, which is sort of an indication of, it's not just economics, but it's where you're located relative to hospitals, where you're located relative to evacuation routes, right? So it's not just an economic indicator. And what we wanted to do is sort of piece all of this together to have some understanding of vulnerability along our coast. Now, this is sort of a pilot study, so we focused on the Outer Banks. But this could be applied to the entire coast of North Carolina. And there are other vulnerability indices that have been developed by other organizations. We were taking a slightly different approach, and our real interest was using sort of this database that we had created for the Division of Coastal Management, right? We had this baseline. Let's start to use that to understand change, to understand vulnerability of the coast. And so this first image, the red and the blue, is just an indication along the Outer Banks where you have erosion, right, the red, versus no change or accretion, the blue. Notice it's dominated by erosion. And in fact, wherever we have looked, wherever we've evaluated erosion or accretion, we're always, almost 90% of our shoreline is eroding, right? That is a process that is currently happening and is continuing to happen and will continue to happen. It's something we need to, at least live with, if not deal with. So that's looking at sort of erosion versus accretion, but we also know what the rates are, and so we can sort of evaluate and put some idea of how vulnerable you are, where the reds are extremely vulnerable, the yellows not so much, and the blues you're not vulnerable at all, just through shoreline erosion. But what we want to do is include some of these other things, social vulnerability, inundation. And when you put that together, and I'll just zoom into one location, put that together, all of these vulnerabilities, you get this HVA, a Hazard Vulnerability Index. And the green in this case is you're not very vulnerable, the red is you're very vulnerable, and the orange is you're somewhere in between. Right, and what I've got here is sort of just a piecemeal of Kitty Hawk. That's what that image is from sort of the southern end of Kitty Hawk. And two pictures during or just after Hurricane Sandy a couple years ago. And you can see in both of these images are areas where we, based on this HVA, this Hazard Vulnerability Assessment, are areas that are fairly vulnerable. And what we saw is during this storm, yeah, they were sort of vulnerable. There was overwash that occurred, there was flooding that occurred, major wave damage both on the estuarine side and the ocean side. Those are places we need to focus, right? We need to think about how these need to change in the future, how we're going to deal with the development that's already there, thinking out 20, 30, 40 years into the future. And these towns are having to start thinking about that now, not waiting until tomorrow. But the shoreline is a moving boundary, right? So the idea of the vulnerability of the coast isn't a line, right? It is also moving. And so as other processes are occurring, this boundary, what we call the shoreline, is changing. Most of it is eroding. And so you can't think, when you go out 10 years, the life of a mortgage, 30 years, that boundary at the coast is constantly changing. And so we have to consider that as we move forward. And so sea level, right? In North Carolina, we don't like to talk about sea level. The fact is sea level is changing, regardless of the processes that are driving that change. Sea level's changing. How it changes 10, 20, 30 years, 50 years, 100 years in the future, we could argue, but we know it's changing. That boundary at the shoreline is changing, and now sea level is also changing, and it's going up, right? That's something that has to be considered. We've got a study going on now that's focused on the entire East Coast, trying to understand sea level, not today, but in our geologic past, over the last 500, over the last 2,000 years. North Carolina has one of the best records of sea level over the last 2,000 years because of studies that we've been doing along primarily the outer banks of North Carolina. And so there's a study going on now that's focused on the entire eastern seaboard. What I want to do is give you some data from eastern North Carolina, an area that's called what we refer to as Tump Point, which is on Roanoke Island. And this is a great example for looking at sea level, historic sea level along any coastline, but our coastline in particular has these very, very thick peat beds, right? These old marsh systems that have basically placed organic matter for years and years and years. And in our case, over 5,000 years and at this place in Tump Point on Roanoke Island. What we can do with that is actually look down core, knowing that marshes are at that interface of land and ocean, right? These marshes grow right at sea level. As sea level raises, these marshes either keep up with sea level or they die, right? And so working in these environments allows us to sort of understand what sea level has done in the past. And so it's got, again, we have one of the best records of sea level in the world. One of the things I want to point out in this particular graph is this is looking at sea level over the last 2,000 years, right? So we're really interested in what's happening today and actually how it's changed, how sea level has changed in our history here in North Carolina. One of the key things is, how has it changed in the last 200 years? And what we can do is look at how sea level has changed with time, and we do see certain periods of time when sea level is decelerated and accelerated, right? And certainly in the last 150 years, we've seen an acceleration in sea level. We can argue about what's going to happen in the next 100 years, but certainly that acceleration has occurred in the last 150 years. And we don't see that just in North Carolina. This is showing the top graph is North Carolina, then you have New Jersey, and you have Connecticut. You see that acceleration in every one of these systems, right? It's not something unique to North Carolina or the East Coast of the US. But we can't just consider sea level, right? In fact, what drives change a lot in our system are storms. And so what we've done in this project is we sort of thought about how's the shoreline changing, and this flow graph is focused on one direction, we look at sea level, from another source we look at storms, right? Because we need to think of these together, right? Sea level is a long-term accretion, right, of the ocean. Storms are a huge punch over the course of a couple days. And so we need to sort of use models, right, these numerical models that can take simulations of storms. This is an example from NOAA taking 10,000 simulations of storms and basically seeing how water levels change within our system. And the reds are an indication of higher water levels, the blues are lower water levels. And you can see in the sound with a storm coming, and I should say with a storm moving to the northwest, that's some indication of what water levels, therefore inundation, would do in our system. Now, what happens when sea level is 20 centimeters higher, a foot higher, and you start putting 3 feet of storm surge on it, right? Those are the things we have to think about, not individually, but together. And then finally, what's going to happen with storms in the future? We talk, we hear about climate change, we hear about what storms are going to happen in the future. There are studies that do show both, right? The most recent study using the best climate models that are out there suggests that at least along the eastern seaboard, we're going to see more storms, potentially stronger storms. Certainly time will tell, but that's what the models are telling us now. And again, we have to consider these things together. And so when I think about our coast, the first thing I would say is that we have a very extensive coast, more so than we knew we ever had, right? More than 12,000 miles of shoreline. And it's diverse, it's fairly complicated, but we want to, that's something that we want to hold on to, and we want to develop good policy moving forward to have that for years to come. This boundary that we call our coastline is constantly changing, and there are many processes that are changing that shoreline even today. And we can't think about them individually, whether it's sea level, whether it's storms, whether it's development, right? All of these things have to sort of come together when we start thinking about how to move forward in the future. And it's, I would argue that it's studies like what we're trying to do that will provide the background information for good policy, right? It's hard to develop policy, management implications, if you don't have data to support it. You don't want to do it in a vacuum, right? We need to understand how this system is changing. And so I'm hoping that some of the data that I'm working on and working with Division of Coastal Management and others helps to develop good policy to sort of save our coastlines. I don't know if that's the right word. Protect, maybe, our coastlines in the future. And I'll stop there.
All right, excellent. How about a nice round of applause for Reide Corbett? And we are going to move into the Q&A portion of our evening. And the way we like to do this is Katie and I, we record all our programs. They stream live on livestream.com and YouTube, and they're archived there later at our museum YouTube channel and at Livestream. And Katie and I have microphones. We like the entire program to be into a microphone. So get our attention, and we'll bring the mic around to you. We'll get to in the order that you raise your hands. And I'll start us off just with this. I'm just curious, you mentioned that we have like 12,000 miles of estuarine coastline, and you said the second most in the country. So who has more?
Anybody? I know the answer. It's not that I don't know the answer.
Anybody want to answer for me? Yeah. Florida, Texas, Alaska.
No. And again, so I said we have the second largest estuarine system. So what's the first largest estuarine system? Chesapeake Bay, right? First largest.
Okay. So we have a question back there.
What will the shoreline, how far will it be inland? How far will the sea level rise within 50, 100, 200 years?
Be precise.
That's not a loaded question. So I guess the answer, it depends, probably isn't good enough, right? But it depends. And some of that depends on where you are. And so I mentioned that 90% of the shoreline is eroding. And it's eroding at rates that range from, a half a foot to maybe 20 feet per year, right? And that depends on where you are, how you're oriented relative to major winds, the types of storms we have during any particular year. And so that's something you have to consider, is the spatial variability that you have across the system. And so you can't apply one single rate, is one thing. Sea level. You can't apply one single rate of sea level in North Carolina. We have a complicated state, right? And sea level is rising anywhere from about 2.5 to 4.5 millimeters per year currently in North Carolina. That seems crazy. 2.5 to 4.5 millimeters. Get it right, scientists, right? But the fact is, our state is complicated. Wilmington, it's only rising at about 2.5 millimeters a year. Duck, it's rising at 4.5 millimeters per year. And it's not because we don't get good data. That's how it's rising. It varies depending on where you are in the state. And so what you could do is take that rate and apply it to 50 years, apply it to 100 years, and apply it to 200 years if you wanted to. Right? That would be a minimum change in sea level. You could take data that we have for much of the state on how shorelines are changing today, right? 3 feet per year, and you could apply 50 years and see where the shoreline lies. But to say, the short answer is it depends, right? The longer answer is we have the data to at least apply some sort of window of where we think the shoreline will be in the future, of where we think sea level will be in the not too distant future. But I'd be happy to sort of look at different areas and provide some guidance, but it's hard to say, this is what North Carolina is going to look like in 200 years.
Don't we have legislation in place to prevent that sea level rise?
There.
Am I misunderstanding that? I thought that.
That's right. I will clearly be fired from my state job.
Our barrier islands, are they eroding and going away, or are they moving inland?
So barrier islands naturally would, as sea level changes, sea level rises, sort of roll back on themselves and work their way up the topography and sort of work inland. Most of our barrier islands are built, right? And we are putting different processes in place to try and prevent the movement of those barrier islands, right? Whether it's some hardened structures, sandbags, beach renourishment, all of those sort of band-aids are to try and prevent the movement of our barrier islands. Naturally, our barrier islands would sort of move backwards towards the mainland, but no, today they're not doing that because they're not strictly natural systems, right? We're trying to prevent that movement because of the development. For right or wrong, right? We are developed. Let's work with the sort of what we have today and sort of moving forward. If you look at some of the storms that we've had in the recent past, the overwash that's created, the inlets that are breached, right? Those are ways, those are natural processes that barrier islands use to slowly work their way backwards, right, with rising sea level. But we have other processes in place to put those islands back, right? And so there are these natural processes that try to get those islands sort of moving back to higher ground, but that's hard to do when you have a built barrier. I hope I answered it.
When you look at our estuarine system versus the Chesapeake Bay, what are some of the differences and the consequences thereof?
It's a great question. And so Chesapeake Bay is a really interesting estuary. It's typical of I would say 30-40% of the estuaries around the U.S. It's fairly large. It's fairly deep. A lot of exchange with the ocean. It's the exact opposite of our system. Our system is huge, right? What do you think the deepest depth in the Albemarle-Pamlico estuarine system is? A little bit deeper than that, but not much, right? I mean, it's really shallow. The deepest depth, if you dig a little hole, could be about 20 feet, right? It's a really shallow system. Chesapeake Bay, you can get 100 feet, right? And so our system is microtidal, which means the amount from astronomical tides from the moon, sun sort of thing is on the order of a few inches, right? Once you get away from the inlets. We're extremely shallow, and so what really dominates is wind, right? I mean, winds can change water levels by a couple feet in just a few hours, right? The astronomical tides can hardly make a difference, right? So that's how it's very different. We have very long residence time of water. What that means is the water coming in from the rivers, on average, will spend about a year in the Pamlico Sound before it exits, right, on average. Which means those nutrients that are coming down spend a lot of time, right, for recycling before they exit. Chesapeake Bay, it's almost in and out. Right, so thinking about the amount of time these nutrients, contaminants, whatever you want to think about, right, there is a lot more time that they can spend in our estuaries, which can lead to some problems, right? It's not like our estuaries have perfect water quality. We are dealing with low dissolved oxygen in some places, fish kills and other things. And that's some of the reason. I mean, those are driven by some of those interesting characteristics. Very shallow, wind-dominated, long residence time. The opposite of Chesapeake Bay.
Hi there.
Hey.
So one of the figures you were showing the erosion and the accumulation rates of sediment in the Outer Banks, and I was really surprised to see the Cape Hatteras. On the southern side of the island, there was sediment accumulation, which surprised me because I thought that as the Gulf Stream is moving from south to north, it would interact with that southern part of the island and pick up the sediment. So I was really curious to understand how it seems to be eroding on the north side, but yet accumulating on the south side.
And so it's a great question. And so that's right. The Gulf Stream primarily, it's a huge current moving from south to north. But what is our dominant winds in North Carolina? What do you think our dominant winds are in North Carolina? Northeast, yeah. So our dominant winds, particularly during the winter, are coming from the northeast. And so in fact, the longshore current, the current that's right along the shore itself, is primarily moving north to south. Right, so yeah, the Gulf Stream offshore, huge amount of water, right? It's like the Amazon times 10 moving north. But right along the coast, everything's moving from north to south. And so that's why you see that sort of difference.
Is the rate of sea level rise increasing due to the melting ice at the poles and climate change?
Yes.
And so if you were to ask this question 5 years ago, right, I'd be up here, oh boy, I don't know if it's changing, I don't know if I should answer this. There has been probably 3 papers, scientific papers, that have come out in the last year, one of them from North Carolina, that has demonstrated an acceleration of sea level during the last 100 years. The question is always, you know, what's the rate going to be in 10 years, in 20 years, in 50 years? Is that acceleration going to continue to accelerate, right? Can we use the rate that we have today to predict what's going to happen 50 years from now? Or do we need to consider an acceleration? And that is always an argument. It's a great academic argument, it's a great political argument, and it's certainly debatable, as most science is, right? I mean, when we start looking into the future, you know, we don't have a crystal ball, right? We're using data that we've developed from the past to try and understand the future. And so, yes, the data definitely demonstrates an acceleration in the recent past. Will it continue to accelerate? Time will tell. The data and the models suggest yes, based on what's going to happen with melting primarily in the Antarctic, the acceleration of melting in the Antarctic, and the continued melting in the Greenland. And so these glaciers that are melting, again, the current data would suggest that those are going to continue to accelerate. The rate of that melt is going to accelerate, leading to an acceleration in sea level rise. Did that get it? Okay.
Yeah, my question's about the length of the barrier islands. I work at Aztec Island National Seashore. Right now we're at 37 miles in length. Cape Lookout and Cape Hatteras are also composed of very long barrier islands. But when we look at the historical maps, they tend to show what appears to be more segmented barrier island sections. Are we witnessing some kind of historical anomaly in the length of our barrier islands, or is there a different force? And when we look at sea level rise, is there an ideal length of an island to defend against sea level rise and make the island more flexible to adjusting for rising sea levels?
Yeah, that's a great question. And if you look at sort of our system, and if you look at, you know, so the historic records that we actually have of inlets in our system, it has fluctuated quite a bit. In the 1800s, we had more inlets present. And if you sort of look at the record of storms, it also appeared to be a more stormy period. You know, again, that's sort of a qualitative correlation there. But there does appear to be some sort of connection between the number of inlets and the storminess that we've had, at least in our historic past. Moving forward, are we going to continue to have more inlets? I mean, I think that's a great question. I think it's a very difficult question to answer. I don't know that there's an optimal number of inlets that we have, but it's certainly not just driven by the ocean side. And a lot of what's important is the sort of the hydraulics on the backside, right? The amount of water coming down our rivers, and there probably is some sort of optimal exchange that system can actually hold. You know, it was really interesting in 2011, Irene, right, when we breached the barrier and they put up this temporary bridge right over Pea Island National Seashore. That was the first time that I know of that DOT didn't just go in and sort of fill in a breach, right? They allowed that basically to do what it wanted to naturally. They put a temporary bridge so people could get across it. And what's happened, it happened over about 18 months, that inlet, right, because it was at one point about 40 feet deep, it closed in, right? And so at the time, right, this exchange wasn't enough to sustain that new inlet, right? That said, we're constantly dredging Oregon Inlet, which is kind of interesting. But, you know, we're dredging it to try and maintain a channel, not because there's not a deep channel, but we want a channel in a particular place. And so, you know, I guess the short answer is I think, you know, right now we're at an optimal number of inlets that the system, because of the hydraulics, the exchange between the ocean and you know, the amount of water that's coming down the rivers can't sustain another inlet with that amount of water exchange. A major storm breaches in, you know, a major breach in the barrier, all of a sudden you have much more water moving between the Atlantic and the estuary. That's a whole new ballgame. And that's a real question for the future, right? There's this this sort of doomsday scenario of a breakdown of the barrier. Is it possible? Well, there's a lot of evidence that suggests that it happened not too far in our past. And so certainly possible.
Hello.
Hey.
Hi, I have a question. Have you measured the temperature of the water, and if there has been a change in it, how does it affect our coast?
That's a good question. And so certainly we've measured the temperature of the water, but if you want to measure change in temperature, you need to measure it over a long period of time. Right? And certainly that's being done in the oceans, and what they've seen is about a 1 degree Celsius increase in the surface ocean. Which doesn't seem like much, but that's having major changes ecologically. Now, I would argue that's one thing that we don't do well enough in North Carolina is we've got the second largest estuarine system in the U.S., but I would argue that we probably have the least monitored estuary in the U.S. There is really no or very little long-term monitoring of water quality within our estuarine system. And so the idea of a long-term temperature record, I'm not sure that we have it.
Yes, I was wondering, in terms of the ecological changes, is that a continuum, or is there a tipping point at which point maybe something like salinity, all of a sudden your changes rapidly increase? And with the data you've put together with your baseline and on all your mapping, do you have a feel for where, if it is a tipping point scenario rather than a continuum, where and maybe even when is that tipping point?
Yeah, and so I can quickly say I have no idea, right? And I would argue that that's where some of the science is lacking, is understanding this connection between the ecology, whether it's aquatic vegetation versus the blue crabs versus shrimp. So the connection between that ecology and what's happening on the shoreline. Right? There's very little science. It's getting better, but I would say it's really in its infancy, trying to understand that connection between the shoreline and what's along that shore zone, and what's happening, the ecology that's happening in the water itself. And so, again, the short answer is I don't know. But as an academic, I could continue to talk about it. But I think there's a lot more that needs to be done, and that's an area that really needs some study, and it is an area that people are focusing on now. And so I mentioned there's a group up in Maryland that's looking at sort of hardened shoreline versus natural shoreline, and trying to make those connections between the ecology, the blue crabs, and the aquatic vegetation, and looking for sort of exactly that. What is sort of the point of no return? Right? And it's probably different for every system, but we can at least qualitatively understand a tipping point. And in ecology, there's always these tipping points, right? So trying to have a better understanding is 10% good, but 15% bad. You'll probably never get to that sort of resolution, but we can at least say, this guy has, this state has 20% and things are tanking, so let's not go there, right? But I don't even think we're there yet, right? The science isn't quite there making that connection.
Hey, so you obviously you've talked a lot about the coastlines changing in the past and they're changing in the future as well. Do you think it would be more feasible for us to focus our efforts on keeping the shorelines where they are in key areas, or to kind of adjust our development around the changing shorelines and just kind of reacting to what happens?
Yes. I think there are ways of looking at that question. An example, all right, in our estuarine system, where a lot of the hardening of the shoreline is taking place is in some of these tributaries of, say, the Neuse River estuary, the Pamlico River estuary. And in fact, where a lot of the hardening is taking place are areas that have very little shoreline erosion. It's more about aesthetics than it is protecting the shoreline that's eroding. And so, those are things that I don't think has been really considered in the past. I think the way, anyway, I'll step on people's toes, I guess. I think the way the permitting process is done now is really sort of a plot by plot basis, right? Not looking at the bigger picture. What we've done is provided them the data to at least consider the bigger picture. Where is all the hardening taking place? Is this an area that we're seeing major shoreline erosion? If it's not, should we think of other alternatives rather than putting a revetment, a riprap? And I think that's the approach we need to at least start with along the estuarine shoreline. The ocean shoreline is a tough nut to crack. And there's not a simple answer. Our ocean shoreline is developed, right? There are many areas that aren't because they're national park and whatnot, but there's a lot that's developed. And so what do you do? Right? That's somebody's property, right? I mean, should we protect it, right? I mean, that's a great question. And should every taxpayer in North Carolina be paying to renourish a beach? Well, you're welcome to come out and enjoy it. Right? And these are really tough questions, and it's not just about science. It really gets into the social issues of how we deal with our coastline. And it becomes really complicated. And I can give you an answer based on the science, but the fact is these questions aren't answered solely based on science, because if they were, we wouldn't have developed there, right? But we have. And we need to deal with that, the fact that it is developed. And nobody's going to move away. I live there. I'm not moving. And so it's a hard question. And I know I sort of skirted your question, but it is. It's difficult because you have to consider the societal questions as well. It's not just a science question.
Yeah. How do you measure sea level? You said it goes up a couple millimeters a year. I'm trying to figure out how you can calculate it, because it's the wind, the temperature. It's going to be changing every day.
It is, and you don't measure it over the course of 1 year.
I figured that.
Yeah, in fact, what they suggest is that you really need 15 to 30 years of data to really have a good understanding of how sea level is changing, right? Because you're right, it changes on a daily basis. There are decadal oscillations that can change sea level. Right? I mean, storms change sea level, and so you need to have a long-term record, right? So, for instance, we've got tide gauges across our coast. I think we have 5 tide gauges that have a 30-year record or longer. Wilmington has over a 60-year record, right? So those are the types of data sets that you can use to understand sea level, but not just a single year, right? And so what we do beyond tide gauges is we go out and collect cores from these marsh systems that have a record of thousands of years of how material has been deposited in these systems. So having some understanding of how marshes sort of grow with sea level, we can start relating, historic and prehistoric sea level through time. And that's what we've done, providing this 5,000-year record of sea level changes in North Carolina. But you're right, it's 4 millimeters a year. It's hard to measure it over a course of a year, and you don't. You measure it over decades.
Dr. Corbett, do you think the marshes are going to be able to keep up with sea level rise?
So North Carolina marshes today, I would argue, are doing quite well. The question always comes up is, will they do well 5 years, 10 years, 20 years down the road? And a lot of that comes down to is what sea level is going to do, right? So today, with the rate of 2 to 4.5 millimeters a year, the marshes appear to be keeping up with sea level. Of all the work I've done in North Carolina within our marsh systems, and I would argue, I guess I have to state that most of that work has been in the Northeast, all the marshes are doing pretty well. They are accumulating at a rate at approximately sea level rise. But if sea level continues to accelerate, then it becomes questionable because, for our system, it's non-tidal. It's not like we have huge rivers coming down delivering a lot of material. And so they might not, just because we don't have the amount of sediment to allow those to keep up with an accelerated rate of sea level. And so I think in the future we could get in trouble. But in thinking about how sea level is changing today and how our landscape is changing, these bathtub models that just sort of flood the landscape, they're unrealistic because that landscape is also changing vertically, just as sea level changes.
Well, Reid, this has been fantastic, and we've covered a lot of territory, 12,000 miles of territory maybe. In closing, I didn't I don't know if I told you this before, but once we finish, people that never raise their hand may swamp you and have questions for you still. But before we leave, we've talked about so many things. So what do you want us to leave here knowing? And I also like to know why, and maybe you could fold this into it, like why you became this kind of scientist, why you specialized here in estuaries, and so why it's important to you, and what do you want us to leave here knowing?
And so I'll go back to what, my sort of mentors have said, Stan and Oren, is the coastline is extremely dynamic, right? North Carolina has an incredibly diverse and complicated shoreline. One solution isn't going to work everywhere. The only thing that's constant is change. And we've got to embrace that. And we can't embrace that by saying people move, get off the Outer Banks, it's not going to work, move away from the coast. We're there. We need to come up with solutions for the people that are there and for the people that want to be there in the future. And there are ways to work with change, right? Developing with change. But you have to consider that change when you develop. You can't ignore it. And in my opinion, North Carolina over the last several years has tried to ignore it. And we've got to get away from that. We need to embrace the science. The science is sound. That's good.
Sound and sounds, yeah.
And the fact is I grew up in North Carolina. My dad was in the military. I grew up on Cherry Point. I grew up looking at the Neuse River estuary almost every day. When I moved back to North Carolina, when I graduated high school, I had to get out. But when I came back, one of the first projects I got funded, I said, I'm going to work on the Neuse River estuary. The first sample I ever took was behind the house that I grew up in. I love this state. I've been around the world studying estuarine systems, coastal systems. I come back here knowing North Carolina has the best coastal systems across this incredible planet. And so I do this work because I love it, right? I mean, I grew up, working on it, playing on it, and I want it to be here for my kids. I've got 2 boys. And the fact is unless we understand these changes, unless we understand the processes that are driving these changes, there's nothing we'll be able to do about it. And so that's really what drives me, sort of wanting to make, as all of us, wanting to make a difference. I'm not looking for world peace, right? That's too hard for me to do. But, I do want to try and make a difference in management of the coast. And I'm hoping, and I'm not a manager, I'm a scientist, but I hope my science can be applied to some of the management that gets done.
Excellent. How about a nice round of applause for Dr. Reide Corbett? And once again, for sponsoring this series of talks with us, APNEP, the Albemarle-Pamlico National Estuary Partnership. We thank them, and you can find out more resources about them online. So thank you very much, and especially because there's so many new people, we have some forms on the table that we ask for a little feedback. We read everything you write, and if you haven't been here before, give us your email address. We won't spam you. We'll just let you know about other events like this that are coming up. Write legibly if you do. And thank you very much, and thank you for all your contributions. Great questions tonight. One more time for Dr. Reide Corbett. And this building is still open till 9 o'clock, so you don't have to go home. You can explore this building for a while, and thank you. We'll see you next time. Good night.
Thanks for coming out.